At the very center of the Milky Way lies an invisible object with a mass more than 4 million times greater than the Sun. This object is known as Sagittarius A. Unlike stars or planets, a black hole does not shine with its own light. It is a region where gravity has become so extreme that not even light can escape once it crosses a certain boundary, known as the event horizon. Yet, paradoxically, the areas around many black holes are among the brightest places in the universe. That brightness does not come from the black hole itself. It comes from the matter spiraling around it. Gas, dust, fragments of stars, and sometimes even entire stars fall toward the black hole and form a structure known as an accretion disk. This disk becomes one of the most violent environments known in astrophysics. Now imagine approaching it in a spacecraft. The brightest ring in the galaxy. From far away, the center of the galaxy appears as a dense region packed with stars and glowing clouds of gas. But as a spacecraft moves closer to Sagittarius A, something strange begins to dominate the view. A brilliant rotating ring of light forms around a dark center. This glowing structure is the accretion disk. It is made of gas and dust, pulled inward by the black hole's gravity. As the material spirals closer, friction and gravitational compression heat it to extreme temperatures. The gas begins glowing intensely. Temperatures in the inner regions can reach millions of degrees. At these energies, matter emits powerful radiation across the entire electromagnetic spectrum, from visible light to X-rays. From a distance, the disk looks like a bright cosmic whirlpool circling an area of perfect darkness. But the closer one gets, the more chaotic the environment becomes. Gravity warping reality. Approaching a supermassive black hole is not just dangerous because of heat and radiation. Space and time themselves behave differently. Near Sagittarius A, gravity becomes so strong that it visibly distorts the surrounding universe. Light from distant stars bends around the black hole, creating warped and duplicated images across the sky. The black hole itself appears as a perfectly dark circular shadow. Around this shadow lies a glowing ring of intensely curved light, known as the photon ring. This light consists of photons that are forced into unstable orbits around the black hole before finally escaping. From the perspective of the spacecraft, the sky would look surreal. Stars would appear stretched and curved around the black hole like reflections in a cosmic mirror. Entering the accretion disk. At some point, the spacecraft would approach the outer edge of the accretion disk. From a distance, the disk looks like a smooth luminous ring, but up close, it is anything but smooth. The disk is made of turbulent streams of plasma moving at enormous speeds. Some regions orbit the black hole at a significant fraction of the speed of light. Gas clouds collide, compress, and heat up as they spiral inward. Temperatures soar to millions of degrees. Radiation pours out in violent bursts. The environment is not a calm rotating structure. It is a storm of superheated plasma moving at relativistic speeds. Flying into it would be like entering a hurricane made of glowing star matter. A storm of light and energy. Inside the accretion disk, the brightness becomes overwhelming. Plasma surrounding the spacecraft glows white-hot, radiating energy in every direction. X-rays and gamma rays flood the region, produced by particles accelerated to extreme energies. Magnetic fields twist through the disk like gigantic invisible ropes. These fields channel energy and sometimes launch enormous jets of plasma away from the black hole's poles. Some of these jets extend for thousands of light years. The disk itself would appear as a chaotic sea of swirling energy. Dense streams of gas would move past the spacecraft faster than anything humans have ever built. Shock waves ripple through the plasma as different layers of the disk collide and interact. Everything here is moving and tearing itself apart. The edge of the abyss. As matter moves closer to the black hole, its orbit becomes faster and tighter. The inner regions of the disk are the most extreme. Here, the gas approaches the innermost stable orbit, the closest distance where matter can circle the black hole without immediately falling in. Beyond that boundary, gravity becomes unstoppable. Material plunges inward across the event horizon and disappears forever. From the spacecraft, the black hole's shadow would grow larger and darker. The glowing disk would appear distorted by gravitational lensing, wrapping around the black hole in strange arcs of light. Even regions behind the black hole would become visible because gravity bends their light around the shadow. The entire universe would appear twisted by the extreme curvature of space-time. Time begins to slow. Near a black hole, gravity does something else that feels almost impossible. It slows time. According to Einstein's theory of relativity, the stronger the gravitational field, the slower time passes relative to distant observers. Close to Sagittarius A, time on the spacecraft would pass noticeably slower than for observers far away in the galaxy. Minutes near the black hole could correspond to hours or days elsewhere. Closer still, the difference becomes even more extreme. The spacecraft would experience time normally, but the rest of the universe would appear to move faster and faster. The closer one approaches the event horizon, the more dramatic this effect becomes. The final boundary. The event horizon is the ultimate border. It marks the point where escape velocity exceeds the speed of light. Nothing that crosses this boundary can return to the outside universe. From the spacecraft, the horizon would not appear as a physical surface. It would simply look like a region where the darkness of the black hole begins. Light emitted from anything falling past that boundary would never reach the outside universe again. If the spacecraft continued moving inward, the black hole would slowly fill the entire field of view. The surrounding universe would appear compressed into a shrinking patch of light above. And beyond that point, the laws of physics as we understand them can no longer describe what happens next. The power of cosmic engines. Accretion disks around black holes are among the most efficient energy-producing systems in the universe. When matter falls toward a black hole, a significant fraction of its mass is converted directly into energy before it disappears. This process can release far more energy than nuclear fusion inside stars. In some galaxies, supermassive black holes surrounded by massive accretion disks become quasars, objects so bright they can outshine the combined light of hundreds of billions of stars. Even though Sagittarius A is relatively quiet today, it may have experienced such an active phase in the distant past. At that time, the center of the Milky Way may have blazed like a cosmic lighthouse visible across intergalactic space. The dark heart of the galaxy. The center of our galaxy is not just a place of darkness. It is a region where gravity, energy, and motion reach some of the most extreme levels found anywhere in nature. Accretion disks transform invisible black holes into brilliant engines of radiation and motion. They reveal the hidden presence of objects that would otherwise remain completely dark. And deep inside that glowing chaos lies the event horizon, the final boundary beyond which the universe can no longer see. Somewhere within the crowded core of the galaxy, Sagittarius. A star continues quietly pulling in gas, dust, and wandering stars. Most of the time, it sleeps. But the disk around it is a reminder that even the darkest objects in the universe can create the most spectacular displays of energy and light.